So some brief introduction to Apache Spark. Why use Spark? Some introduction to it, some basics, hands-on, let's talk about installation and some examples. So quick question, how many people do you know that are working with Scala? How many do you know that are working with Python? And how many are working with other languages such as R and Java, and how many are working with Spark? Well, basically mostly that are working with Scala, Python or R have some usage to deal with Spark as it deals with heavy intensity work over the net and the MapReduce because it increases the performance. Because you see, most of the machine learning algorithms are iterative because in each iteration you take some result and you pass it through the pipeline and improve it until you have a model at the end that you can work with. You start with raw data, you clean it, you add features to it, and you do some iterative process on the pipeline until at the end you have a model, and then you repeat this process. In the MapReduce world, when you did this, then each stage placed its output and read its input. This is MapReduce 1, read its input from disk and wrote its output again to disk. And this is a very heavy process and it's taking a lot of time. This is where Spark execution comes in because it can do some of the manipulations in memory. It does not need a disk for all the operation. In fact, as many operations you can do in memory, the better, the faster things are going to be, and only at the ends you see that it's writing to disk, only at the ends, the first and where is the input, and at the end, and maybe in the middle because it needed to, it had to. But in standard MapReduce, the way that the different MapReduces are talking one with another, it's like a shared memory. I have something to tell you, so I write the output on disk and you read it from disk. Instead, why don't we connect our brains and use our shared memory? It will be much faster, and this will happen in the future. In the future, we will not need to communicate verbally, which is a lot slower. We will simply connect the brains, and this is what Spark does to the MapReduce world. So I won't clutter you with the original date or stuff like this. It doesn't really matter. It's very fast. It could be maybe something like 10x on disk, and the reason is that because also on disk it can do a location. It's smarter because in standard MapReduce you are less smarter about the data. You do run the computation on the node that runs the data, but you are less of concatenating jobs in a similar manner where you know you already have the data. You just need to run the next step. You simply start a whole new MapReduce process, and this is too much. So they claim at least that it's from 10x to 100x. And some other benefits of it is that it's a multi-language library. They support Java, Scala, and Python, but don't expect any function to exist in all the others. It's first a Java and Scala, and then people are writing APIs for Python and R. So in Python and Scala and Java, you can be rather safe that you will find everything. In R, you will find most of things, but not everything. And it's, of course, it's using Hadoop as its underlying layer for running the actual jobs. Within it you have some libraries, just as you would build your modules. You would build them with some underlying core infrastructure, and above them a few libraries. So you have the infrastructure of Spark underlying, but above it you have Spark SQL, Spark Streaming, machine learning libraries, and graph libraries. The good thing about Spark is that, as opposed to Python where you have so many libraries which are doing really good stuff, in Spark it's a more slower process. They are examining exactly the libraries. They don't want to change any future, so you get the machine learning libraries in Spark a little bit slower than how you get it in other libraries, but it's like it's more stable. They think of the long run. The execution flow is that you have a driver program, which is where you send your job to, and it will distribute it with the cluster manager into the worker nodes, where in each worker nodes you have an executor which is running tasks, and you also have the cache. So you talk to the driver program, or you are the driver program, you talk to the Spark context, and you are sending your jobs to the cluster. And this is the execution flow. The terminology is that you have the application jar is just simply a main method in Java or Scala that you have, and you send this main bundled in a fat jar to the cluster. You have the driver program which is responsible for starting the execution of your main function by means of the cluster manager, which is distributing using either you can use the internal standalone manager of Spark, or you can use the yet another resource manager or Apache Mesos, which are Yarn or Mesos, and you can deploy it either inside the cluster or outside the cluster as a client. So you have both ways. The terminology is also that you have worker nodes, is simply the nodes that are running your jobs. You have the executors, which are the internal processes running inside the nodes which are running your tasks, and they try to keep the executors the data inside the memory, or at most in memory, or if cannot then in disk, so that they can repeat and process the same they can continue the pipeline much faster. The tasks are the unit of work, the main that you are sending to an executor, and a job can consist of multiple tasks. This is the pipeline, internal pipeline that you have, and each job you can also the terminology inside Spark is that you can separate each job into stages that are sequential. This is like your pipeline. And you have the Spark context, which is like a mediator. You talk to the Spark context. I'm not sure it's the best name, but it's like the Spark client. You talk to it, and it's talking to the cluster. The RDD is the basic data structure. After that came a data frame, and after that data set, which has a relation to the RDD. So basically what it would mean to you is that you have a collection where you can run simple operations such as smart filter and persist, but you have additional operations such as cache, so you can cache it into memory. The RDD is distributed, as we said, and it has two separate lines of modes of operation, where one is that you are running manipulation or transformations on the data, and another is the actions. So as we said, you can use Spark without a resource manager, simply a standalone deployment mode, and you run your jobs with it. You can run it, of course, with the other resource managers such as Mesos, Yarn, and Cloud Clusters. When you want to monitor your jobs, you go to usually port 4040 stages. As you remember, the stages are inside the job, and you monitor their statuses. And here we see that the tasks that are successful, 735 from 1000, it's a simple monitor for your jobs. You can see also the percentiles of where jobs exist and their status. Again, in port 4040/stages. So let's see some examples. So this is an example of how you run the Spark shell. So you go to the directory where you simply need to download Spark into your local computer. After you have downloaded it, you just go to the bin directory, Spark shell, management master local 2, which means use 2 cores, and you run it. And you have a Spark shell where you can simply do some operations with Spark. It's like a Scala shell. Or you can simply run a whole example by running some examples, internal examples from Spark. Some basic operations is load a text file, which in return will return you an RDD. You see, here we access the Spark context. This is like our entry point into a Spark, and it returned an RDD. Today we're using a data frame and dataset. And you can do count. Once you do a last operation, it has to actually fetch the data to you, because when you do the internal transformations which are not count or first or collect, then this transformation can be concatenated in a functional way. And you can do, of course, filters and map and all the goodies that you have as collection. At this point, I want you to think as Spark simply as a collection library where you run many functions. And you can do a caching. When you do caching is that when you do intermediate operations, it will already be cached, so it won't need to reload the data from disk. And of course, you can load a text file from the HDFS with spark.txt file and the URL to HDFS and continue as usual. In Scala here, what you see is that we import some stuff from Spark, and we simply, it's no magic. I mean, it's just an object and the main method, and you do your work inside the main method. The main thing to look here is that we do new Spark conf, we give it an application name, and then we initialize the Spark context. We also go with the Spark conf, the master local, and we now give the Spark context the conf. So with a few lines, you're having your job at least starting. Now you need to fill in your actual data. And in Java it's very similar, new Spark conf and the app name, new Spark context, and once you have the Spark context you begin manipulating your data with filter, cache, and whatever you want, count. You see, it's pretty straightforward. And in Python, again, almost the same API, Spark context, you initialize it with you saying that I have a local a Spark and the text file from the log file, and you start doing your filters and the count and print the result. The way to submit a job is you, in the directory that you download Spark, you go to bin and Spark submit. You tell it your main class name, how many threads you want to use, and your fat jar that you want to submit to the cluster. It will take this jar, pipe it to the cluster and run it and get back with the results. And as you have seen previously, we had a new Spark conf, which is the simple few lines that you need in order to instantiate a Spark in your code. So you do a Spark conf, and you can give it some parameters, and this is the executor memory, and you do a new Spark context, and you have the Spark context. So thank you very much for listening, and I will see you next time. This was a brief introduction into Spark.